application is seen here. So yesterday, I think most of you have understood the limit of the sequence. What is the code definition of the limit of the sequences? We have seen given epsilon, recall. Sequence Sn is said to converge to a limit L. No, not convergence. Limit n tending to infinity of the sequence is equal to L. If given epsilon greater than 0, there exists M. As I said, M may be some textbooks real number, some textbooks natural number. Depending on the question, you answer. Such that, what is the condition? Modulus Sn minus L.
Screen is not seen, visible, ma'am.
Huh?
Screen.
Yesterday's definition. If given epsilon greater than 0, there exists an M such that Sn minus L is less than epsilon. So depending on the epsilon, we can have the number, that is M. So we have seen in one case, 1 by n square we have seen. You can have similarly for any given question Sn, you can apply the definition, get the M value. And one of the best applications given in one of the papers indirectly is this. Given in one of the set papers, I would like to work out this. But before going to that, I want to give you some standard limits, which often we'll be using while evaluating this. So note down some standard limits. Standard limits we use in this course. First one is limit n tending to infinity. 1 by n power alpha is always 0. Whenever alpha is greater than 0. What is the application of this? Where are we going to use this? Here alpha is greater than 0. Nothing given means it can be real number. Real number means it may be for rational number. Alpha can be integer, rational, anything. Anything positive. So for example, what is the application of this formula? Limit n tending to infinity 1 by cube root of n is given to you. Let us say cube root of n. Yes. So I can use this. You have to write this in the form n power something. So limit n tending to infinity 1 by n power 1 by 3 cube root 1 by 3. This is in the form alpha 1 by n power alpha. Alpha is 1 by 3, which is positive. This is alpha. Therefore, according to this, whenever alpha is positive, whatever may be alpha value, the limit answer will be always 0 by this form. You can use even root n. Root n means n power 1 by 2. You can have even n power 100, n power 1000. Alpha can be anything which is positive. Rational fractions, integers, anything, then automatically answer is 0. So 1 by n square, limit 1 by n square 0, 1 by root n 0, 1 by fifth root n 0, 1 by n cube 0. So we'll be using directly this. Next, another standard result which we'll be using is in this course, limit n tending to infinity, x power n is 0. Yesterday we have used this. If mod x is less than, so it's applicable even for negative also. So whenever it is less than 1, it will be 0. If it is greater than 1, it is infinity. That is what we have used yesterday. So you can see here x can be anything. What is the application? For example, limit n tending to infinity 1 by 2 power n. Answer is 0 because your x is 1 by 2. Mod x is, mod means if it is positive, it is itself. Negative, we should take it as positive. Therefore, this is 0. So limit 1 by 3 power n 0, 1 by 4 power n 0. This is one of the applications. And also, wherever you come across limit n tending to infinity, minus 1 by 3 power n is. So it is in the form x power n. X is minus 1 by 3. So mod x will be mod minus 1 by 3, 1 by 3, which is less than 1. Therefore, limit of this is automatically 0 according to this form, because mod x is less than. So it's applicable not only for positive, it's applicable for minus also, because modulus, as long as modulus of this is less than 1. Next, we have another standard result. Limit n tending to infinity, n power 1 by n is 1. We are going to see the proof of this again. All this in L hospital rule applications, you can see the proofs of all this. N power 1 by n is 1, standard result. Another standard result which we'll be using is limit n tending to infinity, 1 plus x by n whole power n is e power x. Shall I use constant? E is e power e, where a can be any real number for all a belonging to R. A is a fixed real number, it's e power e. If a is 1, it is nothing but the is equal to 1, often used when a is 1, limit n tending to infinity, 1 plus 1 by n whole power n, e power 1 is e. What is e is? It is an irrational number. Its value 2.71 something. It is between 2 and 3. E is irrational. It is irrational number. Its value is between 2 and 3. And e is between 2 and 3. It is 2.71 and so on. So it is between 2 and 3. So this we will be using often. So number 6, limit n tending to infinity. This is also often used. Log n whole power a by n power b is 0 for all a positive, b positive, real numbers. So a positive, b positive, limit log n power a by n power b is 0. And number 7, whenever you have limit of some function, limit of suppose a power n or sn is 0, and another sequence tn is bounded. Bounded means modular upper bound exists as well as lower bound exists. Then very interesting is limit of Sn into Tn is same. Can use instead of flower bracket, this bracket also I can use. This is same. So whenever this product, one of them is bounded, the other is limit is 0, then this limit is 0. What is the best application of this is example. You know, all of you must be knowing sine and cos are bounded functions. Mod sine theta is always less than or equal to 1. Mod cos theta is also less than. These two are bounded functions. We cannot say for tan, because tan 90 is infinity, unbounded. Tan of minus 90, minus infinity. We cannot say for tan, but sine and cos are always bounded functions. And moreover, the lower bound for this is minus 1. Upper bound is 1. We are able to find k1, k2 such that sine theta is between them. So this is lower bound, this is upper bound. So it's bounded for all theta. Similarly for cos theta, least value cos theta takes is -1, greatest value it takes is +1. So these two are bounded functions always, whatever may be your theta. Sin theta, cos theta are bounded functions. So what is the application? The application of this is, example, limit n tending to infinity 1/2 power n into sine 3 power n is. Generally, what students think is, this is okay. Sine 3 power n means 3 power infinity. Infinity. So sine infinity, infinity they think. So don't apply directly. Whenever product is there, this is your Sn, this is your Tn. It can be in any order. So one of the sequences is 0, limit is 0. This is in the form 1/2 power n, x power n form, where mod x is mod 1/2 less than 1. So this is automatically limit of Sn is 0. This side, so I have used this. I'll use this symbol. Sequence, this symbol. Because we are using this flower bracket or open bracket in some textbooks, they use for sequence this symbol also. This symbol, this symbol. 3 are used. You should understand whatever it is. So this is limit of Sn is automatically 0. Limit 1/2 power n is 0. And you know, this is in the form sine theta. Don't apply limit. First simplify, then apply. Sine 3 power n modulus is always less than or equal to 1. So this is a bounded function. Yes, this is Tn is bounded. Therefore, one of them is 0, the other is bounded. The answer is 0. This is also one of the best applications of this. So instead of sine inside, anything can be given. Whatever may be inside. Outside sine is there means it is bounded. Remember that. Inside it can be sine n square, anything. Don't look at inside. Only whether sine is there, cos is there. If it is there, automatically bounded. This limit you find. If it is 0 only, 0 into bounded function is 0. If this is 1, don't write 1 here. If it is 0 only, this rule works. If it is anything other than 0, we cannot apply this rule. Okay, next. Let us go for another interesting application of this. Here, the question itself, given in one of the papers. Very interesting question. This I want to. Let us see. If xn, given in one of the papers, xn is this for all n belonging to n. If the limit of the sequence is k, then largest integer, not largest, least. The question itself is, there is some mistake. The least integer, not less than k is. This is the one. This is, please eliminate this. Question mistake is there. So this is the one for all. Limit of the sequence is k, then least integer not less than k is. This is the one. Let us see. Very interesting. So here if I take limit xn, limit of the sequence is k. How to find the limit? Let us see. Limit of sequence is, this is the nth term of the sequence. So limit of xn, limit of n tending to infinity of 1 plus 4/3n whole power 5n by 7. So This can be rewritten in the form limit. Limit means limit tending to infinity. That's how we understand this. 1 plus 4 by 3 by n whole power n whole power 5 by 7. I'm rewriting 1 plus 4 by 3n, 4 by 3 by n. 5n by 7 is n into 5 by 7 because n into 5 by 7 is 5n by 7. This is nothing but limit n tending to infinity. This is in which form? 1 plus a by n whole power n. We have seen just now limit of standard limit. 1 plus a by n whole power n is e power a. Whatever may be your a. A is real. You can see here this 4 by 3 is real. This is 1 plus a by n whole power n form. A is 4 by 3. So this will become e to the power of 4 by 3. Whole power 5 by 7. Which formula we have used? Limit 1 plus a by n whole power n is e power n. Instead of a, we are having 4 by 3. So this will become e to the power of, this is limit xn, is e to the power of 20 by 21. This is given to be equal to k. You can see if the limit xn, limit of the sequence is k. So the limit of the sequence whose nth term is xn is k. Limit xn, the sequence xn, nothing but limit of the nth term is k. So k is equal to e to the power of 20 by 21. So we are asked to find something. So we need to know what is the value. We cannot simplify this. So we know 20 by 21. Numerator less than denominator means it is less than 1. Numerator greater than denominator means greater than 1. Whenever you have a fraction a by b, general rule is less than 1 if a is less than b. Greater than 1, I'm talking about positive numbers. A is greater than. And we are any natural numbers. This is 1. A is equal to. A is positive number. I'm taking. And A and B are natural numbers. Positive number, integers. Then whenever you take a fraction, numerator less than denominator means less than. It is positive. This is e power we want. So e power 0 is less than 20 by 21 because exponential is increasing function. E power 1 is. This is your k. E power 0 is 1 less than e. What is e 2.7 something? So e value is between 2 and 3. So we can rewrite this as 1 is less than k, less than 2, less than e, less than 3. This is the situation. So the k value is less than 2. It is between 1 and 3. This value is 2.7 something. Less than that. So k is less than e. So after k, the integer, least integer, not less than or equal to k. Integer not less than k. Not less than k means that is least integer. Least integer not less than k means least integer not less than k means greater than or equal to k. Least integer greater than or equal to k. So greater than k, k value is less than 2.7 something. So after k, what is the greatest integer is? What are the integers? It is less than 2.7. So after this, what is the integer is? It is less than 2. Less than 2. K is less than 2 definitely. So what is the integer for k is? The value is, first integer will be 2 because k is less than 2. Greater than k, what is the integer is? Integers are greater than k. What are all the integers? K is not an integer. Integers are greater than k. Integers greater than k are. What are the integers? K is less than 2. So it is 2, 3, 4, and so on. These are all the integers greater than k. Not less than k. That means greater than k. K is not an integer because it's between 1 and 2. So greater than k, what is the first integer is? It is 2, 3, 4, and so on. If the answer is largest, there is why mistake in the question is, if it is largest, then infinity is the answer. There is no integer greater than that. So it should be least integer. So what is the least integer is? Integers greater than k are 2, 3, 4, and so on. Least among them. So least integer is not less than k. Not less than k means greater than or equal to k. Is 2. Least among them is 2. So answer is 2. This is the answer. I'm repeating once again. You are given limit of the sequence is k. How to find limit of the sequence? Limit of the sequence is limit of the nth term. Yesterday we have discussed. How to find limit of xn? Take this to the power phi n by n. This I'm rewriting. 1 plus a by n whole power n form. Because phi n by 7 is n into 5 by 7. This is nothing but e power a to the power 5 by 7. This formula we use. E power 20 by 21. This is k. So I want to conclude something about k. So k is e power 20 by 21. 20 by 21 is between 0 and 1 because numerator is less than denominator. E if you take, it will be between 1 and e. E is between 2 and 3. So 1 is less than k is less than 2, and the e is between 2 and 3. So integer not less than k. That means greater than or equal to k. So what are all the integers greater than k? First integer greater than k, yes. 2, 3, 4, and so on. Least among them is 2. So 2 is the answer for